Hey guys, I'm Edward from 1010G, and today I'm going to be filming a robot explanation video where I go over some of the features on my robot and explain my thought process and design process behind this robot. So I thought that since we've had this robot for a while now, since like November, and it's going to its last tournament next weekend, which is our British Columbia Provincials. I thought that'd be a good time to share my design, and yeah, hope that it can help some of you guys out. And if you guys have any questions, feel free to leave them in the comments, or you can message me on Discord, and I'm happy to help. And yeah, so let's get started. Okay, starting off with our hood, we have a one single 11-watt motor powering our hood, and we have it chained from 600 RPM to 400 RPM. And our hood is pretty simple. It's just a simple hood design where the ring goes in from the bottom and floors off from the top. And probably the most unique part of our hood is the fact that we only run 3 stages. And so with the reason for running only 3 stages is basically because the less stages you have, the less friction and load there is going to be for the motor. So yeah, that's about it. And we're able to do that because of obviously the flaps. They push the rings up further, so I space the stages out further. And so what I think is more interesting is why we went with hood. And so I'm going to try my best to explain that right now. So starting off with probably one of the smaller reasons is just ring control. As you can see with hood, the ring is controlled all the way from top to bottom. We have control of the top, sides, and bottom of the ring. So what that means is that the ring cannot physically fall out of our hood ever. It's either going out the intake, going in from the intake, or going out from the hood. So this is really good because it ensures that every single ring we intake is going to do what we wanted it to do. So if we accidentally intake the wrong color ring, we're going to sort it. If we intake the right color ring, it's either going to go into our arm for wall sticks or it's going to go into the goal. It's never going to do anything unpredictable. It's never going to fly out like on hooks, and it's never going to not do what we tell it to do. This is really nice because I think consistency is probably one of the most important parts of robotics, and at least VEX robotics. So yeah, that's one of the reasons. And another part of why we went with hood is how this top part here works. So as you see with hood, we have this, like, this is pretty much the hood, right, that pushes the ring down. What's really nice about this is that it's kind of like a cage for the barb. So as you see that I've seen a bunch of other teams use their short arms to score onto the goal while you're possessing it. So they're just driving behind you and they just plop the ring on. So that's really obviously a really crazy play, and it allows for a pretty big point swing as you get the top ring on your goal. But with hood, it's physically not possible. As you see right here, we have this physical barrier, so it ensures that we're the only ones that can interact with this scoring object. And so next up, that plays into our clamp. So we have a pretty standard clamp, 2 pistons, top-down clamp. And probably the most interesting part is how it's very long. We have it mounted on this crossbar. You can see right there. This is the clamp. And so it's like mounted halfway across the robot. So this just makes the clamp have a lot of torque and a lot of power pushing down as the pistons have way more leverage. And yeah, this just helps the clamp be very strong and difficult to pull out. And that combined with the fact that it's top down makes this goal pretty much unstealable and undrag-outable, like it can't be dragged out of our robot. And so now you probably noticed that the goal is tilted at a pretty big angle. And I'll put the ring here for comparison. It's tilted way more than the ring. And so the reason for this is basically so that teams that try to use their Doinker, like goal steel clamps, or their actual clamp to grab onto our goal and drag us, or grab onto our goal to score onto our goal or whatever, for whatever reason, they can't because the goal is tilted so much. And so this just, with all of these things that I just mentioned combined, it pretty much makes sure that this goal is very, very secure. Yeah, that's about it for the goal and the hood. And so now I'm gonna probably talk about the most interesting part, how to reset this, but how it works with our wall stick arm. So wall stick arm is probably the most interesting part of this robot, the interaction between the hood and the wall stick arm. And I'd say it's the biggest reason for why we went with hood. So I'll demonstrate this right now. So you'll see that the rings get loaded into the arm with the hood by pushing this way. So the reason that we went with this is because you'll see how this ring is loaded, like I just demoed, versus with hook. So for example, if this was a hook conveyor, it would load up, and then they would want to start pulling down, obviously at the top, because you need hooks flip the ring onto the goals, right? But what this means is that when you're at the top, the loading geometry and angle of the force that the hook wants to go is not very optimal for the arm, as it limits you to how far you can load the ring and at what angle you can load the ring at. So that's why you'll see on most hooks, when the ring is at the top, the ring is loaded at around this angle and not nearly as far as this ring. So you'll see that when it's loaded onto our robot, the ring is loaded so far, it's actually over the goal. And so if we just imagine that this was hook instead, the ring would probably be loaded somewhere around like here, as there would need to be a gap between the center of the rotation point of the hook and the goal. And so that means that you would only be able to load the ring up to about this point. And also at a non-optimal angle. And so yeah, that's the first part of ring, how the arm is able to get so much reach. And the second part is this. So you'll see that right here, when our hood loads the ring on, the ring is loaded with only holding the bottom section of the ring. This is like maybe the bottom 2 inches of the ring. But versus with hook, I'll just push it down. Most hooks load their rings about here, about at the middle point. So leaving only like 2 inches at the top. And so this is just because of how like I explained earlier, like the force of the hook, and just how it works, where you can't physically push it up since the hook is trying to flip down. But with hood, the wheels are always trying to push up, so that's why we're able to load it past that point and hold it in a more optimal way and higher. So this allows us to fully maximize the amount that the ring and optimize the range. And so I'll quickly demonstrate the scoring now and talk a little bit about why the geometry that we score at is more optimal than the geometry that most hooks score at. So you can see here, I can move, I can move the robot all the way like back here. This is more than like, there's almost like 3, 4, 5 hands of space here. So this is a crazy amount of reach. And so you'll see that the robot is still, yeah, okay, that's a little too far. But you can see still crazy amount of space, and we're able to still score that ring on. So this is probably around the max range for our robot. As you can see here, it's this is where the tile is. It's about half the tile, and that's like the maximum range that we're able to get. But we score way more consistently, just about right around here. So maybe like 10 inches. You see all the way down there. And so, yeah, so the reason why scoring at this angle is more optimal with the ring basket like this is because you'll see that when the ring is coming down here, the ring is not actually the center of the ring is not actually even close to the top of this. But because of how the ring is designed, like it's circular, we're able to use the ring sort of like a funnel, like a wedge, where it funnels itself into the top of the ring, into the bar. So this just increases our range by even more. As you know, most hook lady brands score from this angle. So this is not using any of the rings, the ring at all to your advantage. It's pretty much just forcing the ring on from this angle, where your arm is pretty much right here. So you're not actually gaining any range. And so yeah, that's how we're able to get so much range. And I'll quickly mention some of the advantages and the reason why we actually want to have so much range. And so one of them being scoring from in auto. So you can comfortably score on the wall stick from like pretty much, yeah, like right here. So you'll see that this is like way more than crossing auto line. If we just drew the tape here, this is like more than a whole ring space of not getting crossed auto line. So this is really nice because it ensures that you'll never risk crossing auto line, and it allows you to score the wall stake quicker and more easily, as you wouldn't have to drive up as far, and also you have a larger range of options, because look, we can score it from like this, we can score it from like here. So yeah, that's a lot more optimal in auto. And another thing that's really nice about the scoring angle is that with this angle, you'll see, like I said earlier, when we're at the maximum range, we're able to use the ring to its full advantage. It also applies to if we're not alive. So for example, right here, you'll see that our arm is off by so much, like we're even hitting the barb, but just because of how the ring is designed, even if we're off by this much, you'll see that the ring, okay, well, it didn't pop on, but the ring is still able to get scored, as the ring sort of guides itself onto the barb. So this makes it a lot easier in auto, a lot more consistent in driver as well, as in under heavy defense and high pressure situations where you can't fully get aligned or you're not 100% sure. It helps a lot. It just makes our window for scoring so much larger. And yeah, so that's autonomous advantages. And so in match, like I was just saying, the driver has so much more options, and he can score from pretty much right here at close to 180 degrees. And so this means you can score from here, 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 here. So whatever angle that he's coming from to the wall stick, he can score at that angle pretty much. So this makes it a lot faster and a lot easier on the driver. Unlike for most robots, you would have to drive up to almost perpendicular to the wall. And on probably the long arms, that I've experimented with for hook, you can get up to probably a max of like 45 degrees, but not much more than that. And yeah, so also I'll talk about how our aligner plays into our extremely long range. So as you see, our aligner, it's extremely long, longer than most, and that's because of how long our range is. We're gonna build fully optimize it, so we have a flip out like that and start the match. And some of the benefits for this is, first one being, let's say this was filled with our opponent's rings, and we're pushing it into the negative, well, this is the positive corner, but pushing it into the negative corner. When we're pushing the goal, you'll see that the barb is being fully covered. And so what this allows us to do is have like a pretty good possession of the goal, as the only way for them to get this goal out would be to physically have us move out of the way. So we're driving to the negative corner, and we hold it like this. Their untippers can't get to this because the the funnel, like the liner, physically is blocking the barb. So they physically cannot untip this and get this out of the way, as their arm would never be able to pass this or whatever flipping mech they have. And so that also plays into corner defense. So you'll see that, let me get another goal. If we are holding our goal here, holding our corner, this is our positive corner, that means that the short arms have a lot harder time to getting into this corner, as this completely blocks off a huge chunk of the area. So the arms that are trying to flip over this or any flip mechs can't really get past this. So it makes our robot longer. So it makes holding the positive corner a lot better. And that plays into our drivetrain. So we also optimized our drivetrain for basically what we saw was a lot of teams were going with these light, fast, super fast, light drift drive robots. And so we now found that if all these teams are going with these light, fast robots, why don't we just go with a slightly slower drive that's on traction and just build a heavy robot, and we can just bully like every other team. So that's why we went with 2.75, 450 RPM on 6 motors. So what this allows us to do is pretty much just, with 4 tractions, it pretty much just allows us to outpower any team that we play against. And they have really no chance at pushing us, as this robot's really heavy. I know a lot of you guys were asking about the weight. It's like 19 pounds. I weighed it today, and yeah, that's a lot. But I didn't actually try to do any weight saving for this robot, and I don't think that the weight really matters at a certain point, because if your drivetrain isn't struggling or having any issues, why would you make your robot lighter? It's kind of slightly faster acceleration, but we didn't really find that to be something that we really care that much about, as we think that the drive is fast enough. And if you guys want to watch our gameplay, you can watch our mecha matches, or yeah, ask me and I can send you guys some of our matches. Yeah, and so with this drivetrain, it means that we can't get pushed from the side, right? So holding corner then becomes a lot more safe as well. No one can outpush us, and that applies also to the wall sticks, as when we're right here with our arm up holding a goal, there's absolutely no way anyone is getting this wall stick. We covered pretty much the whole 2 tiles in front of the wall stick, and no one out pushes us, so it pretty much the moment we camp in front of the wall stick, it's guaranteed. And yeah, so this isn't solely just a off defensive drive, of course, as a lot of teams think that the faster and the drift makes you more offensively strong, but I actually found that it's not completely true, as being faster is nice, but I think that actually being slower and having more torque and traction drive helps you more under defense, because when you're under heavy defense and they can't really push you very much or barely move you, it gives you a lot easier time to score. Because with drift, the only way where you can score is if you completely bait them like really hard and they completely like stop following, and then you can get an opening, right? But if you're on traction, if you don't find that opportunity, it's fine, because we have such big range where if they push us slowly it doesn't really even matter, because we can just still get that wall stake on. So our robot's been really good for scoring wall stakes under defense in both quals and elims. And yeah, okay, so now talk a little bit about the Doinkers. So you'll see that this is pretty unique right here. I mean, pretty interesting. This is basically our gold Steal Mech that we made after Mecha. We thought that we really wanted like a win condition, something that like we can do consistently. So I designed this, and basically how it works is when it's up like this, I'll have a goal. When the goal slides in and when piston goes up, the goal is locked in here. And so this isn't like most piston powered clamps where you have a piston that holds the goal. It's like something that physically locks the goal, because you're pulling against like the dowel, right, which is not going to snap, or most likely won't, which is a lot stronger at least than a piston is. So this ensures that once we grab onto the goal, we pretty much have like full control and can hold the goal very securely. So the plan with this was, if you go over to the corner at like maybe 30 seconds, I mean, sorry, not 30, like 45, 20, 40, 45, 50 seconds, you can just go over there and just go like really push and bully the other team holding corner. And because of how long this arm is and skinny it is, you can get the goal when it's in the corner. And yeah, we basically found that this design is very not easy to, like, this thing is not easy to pull off at all. So we just probably gonna be taking it off sometime. I'll probably take it off after I film this actually. But yeah, I thought I'd just share this. But this is still very good for goal rush. So if anyone looking for a good consistent goal rush design, this is very nice. And oh yeah, you might be wondering what this is for. This is basically, it's kind of hard to show this. It's basically like, if the goal is tilted, you can still get it. So yeah, it's basically counters like if the goal is sitting in the corner, like at an angle, or if your opponent for goal rush tilts the goal up. Yeah, and as you guys probably mostly saw our autonomous showcase video, where we grabbed 2 middle rings with the Doinker. And yeah, it's basically just because we have such a long Doinker, we're able to space these 2 standoffs out far enough to grab both of them. But we decided to scrap that design, and we no longer do that. We just stick to grabbing 1 ring from the middle. Because what we found is that it takes so long to line up properly for these two, for this single Doinker to grab both, that it's not really worth it, and you might as well just take one quickly. So yeah, and also it wasn't consistent enough, especially with other people setting the field and that 1 inch tolerance on the rings. It just wasn't consistent enough for us, so yeah, we decided to stop using it. But what I'll say is having these long Doinkers, this is very, very long, is something we found really extremely useful, as when you're sitting in the corner, you're really able to take advantage of it by dragging rings back to you, or also if just a ring is in an awkward place, it's easy to put the Doinker down, drag the ring out. And yeah, sweeping corners, it works fine. So yeah, that's pretty much it. Let me think, what else we got? Oh yeah, wait, color sword. You guys were waiting for that. Okay, yeah. So a lot of you guys asking about how the color sword works, and I guess it does look kind of complicated, but I think it's actually a very, very simple design. And second. So how a color sort works is, you'll see here when the arm has a piston on it. And so the reason for this is, there's multiple reasons, is because we want to have a loading state and a scoring onto goal state. And so basically the color sort, basically when it's open, the rings go in. Let me grab blue ring real quick. Okay, so you see if we get a blue ring, it's not on in driver because it's just not consistent enough, because for driver you're not holding down the intake at all times. But you can manually do this in driver control. And so basically, if you're intaking, you can just close the clamp when you see the blue ring coming, and you see that the blue ring is being held by the arm, and so it can't fall into goal. And then when the next ring comes, it just pushes it straight out. And so you can choose whatever you want to do with the ring. Put it back on. Score more, and then when the blue one comes, you just close it, and then it gets held, and the next red ring pushes it out, and then you score the red one. Yeah. So we just in code we do this with the optical sensor, of course, and this little cage thing that we have here is really nice because it blocks the light from whatever light source it is, so it keeps the sensor for the color for the ring consistent. And basically this cage is not fully decorational. It's also because the gap we have between these two stages is so much that without this, the ring actually wants to go out this way from the top. So I had to put this on, yeah. Oh yeah, and so how we do Aliance Stake. We have two Aliance Stake scoring methods, and so one of them is for drivers, and this is what we use in driver skills. And also we could, if we wanted to, in auto. Although it's kind of hard to drive with one hand. Okay, so you see, you line up to the stake. It's actually really simple and consistent and easy to use. I think it's probably easier than the hook ones where you have to get the hook spacing perfect. But you back up and just move forward. And you see that's on. And so yeah, we use this in skills, and also if we ever, for whatever reason, miss it, the line stick in auto. But it's we never really do, because we score the line stick in auto in an even more consistent way. Basically, as I said earlier, we have a flip out aligner. When the liner flips out, it pushes that ring. This is really good because it's really quick. It's 300 millisecond delay at the start of our auto. It's also very consistent. Yeah, thank you guys very much for watching the video. If you guys enjoyed, please let me know. And if you guys want to see more stuff like this, or have anything else you guys want me to make a video on, please let me know. Leave them in the comments, and I'll see what I can do. Yeah, sorry for the long video. Kind of yapped for a long time, but yeah. Hope you guys helped. The video helped, and yeah, see you guys.